wondered what it means, and maybe you haven't. Maybe you already know what it is, maybe it doesn't matter. Sure. Anybody know much about exponents? What is an exponent? What does it do? Anybody? I've got that thing there. Grace?
The little number?
This little number is called the exponent. Make sure you write that down. Another name for it is also known as, aka, a power. What does that little 2 mean or do? Nick?
It makes it 4 times 4, so it's 4 to the second power.
Okay, what it does, and write this down here. The exponent. Uh-oh, there we go. The exponent tells you how many bases, I guess I better, how many bases get multiplied together. Which isn't going to make any sense until you tell you that this is the base. The little number is called the 2, the big number is called the base, and the exponent tells you how many bases get multiplied together. I'll give you a chance to write that down before we go any farther into that. The exponent tells you how many bases get multiplied together. Got that written? Now please, let me start by telling you this, boys and girls, this is not 4 times 2. The answer to this is not 8, okay? Otherwise I would have written 4 times 2. Okay? This is 4 to the second power, which means you have 2 4s times themselves. The exponent tells you how many of these numbers get multiplied together. 2 of them are getting multiplied together, so you get 16. Okay? 4 to the third power means that you have 3 4s being multiplied together. 3 of them. This little number here, 3 exponent tells you how many of that same thing get multiplied together. 4 times 4 is 16 times 4 is 64. Take my word for it. But I can tell you zillions and zillions of times for the answer to this, people tell me it's 12. And it's not, because it's not 4 times 3. That would be 4 plus 4 plus 4 was 12. But this is all multiplication. It's 4 times 4 times 4, which is 64. Okay, and we got a couple other, well, let's do a couple more examples and then we'll talk just a little bit more about that. So, if I gave you 8 to the second power, what would that be? It's not 16. Michael, it's?
8 times 8 is 64.
Correct. It's 8 times 8, which is 64. I gave you 1 to the second power. This is always a fun one. 1 to the second power is, Alexa?
1 times 1.
Which is?
1.
Correct. How about this one? 1 to the 10th power. Jacob?
10 times 1.
No, it is not 10 times 1. You already fell. Alrighty, it's only been 3 minutes and you've already done it to me. If I wanted 1 times 10, I would have written down 1 times 10. What does 1 to the 10th power mean? It means I have 10 1s times themselves. How many more do I have to go? 1, 2, 3, 4, 5, 6, 7, 8. And what do I get if I multiply 1 by itself 10 times? Calvin? 1. Sometime in your life, you will hear the term something is growing exponentially. Okay, sometime in your life you'll hear that. Probably before you're out of high school. What does it mean to grow exponentially? Well, that means this. Okay, the thing with exponents is it doesn't take very long before exponents start making numbers really, really big. For example, 5 to the second power is just 25. 5 times 5. But 5 to the third power ends up being, well, 25 times 5, which is 625. And 5 to the fourth power, if you start multiplying another 5 times that, you end up with, well, 5 times 625, which is what? 3,625, I believe. Oops, 3,625. Okay. Could you imagine what? I mean, if we kept going with this, even 5 to the 10th power, you know how big 5 to the 10th power would be? Very large. Even if you're doing 2s, 2s is about as easy as we can get. 2 to the second power is 4. 2 to the third power is 8. 2 to the fourth power is 16. Okay, and what's going to happen is these don't grow very fast. Okay, they're kind of slow growing, but as you get farther and farther away, it starts to grow really fast and then really, really, really fast. For example, 2 to the fifth power now starts to be 32. 2 to the sixth power is 64. Still not growing real fast, but when you get to the seventh power, 128. 2 to the eighth power, anybody? 256. 2 to the ninth power,
512.
512. 2 to the 10th power,
1024.
1024. 2 to the third, what are we at? 11th power, 2048. 2 to the 12th power, 4096. 2 to the 13th power, 8192. 92. Okay, so when you hear exponential growth, what it means is things start kind of slowly growing, but then all of a sudden they start getting faster and faster and faster and faster. I mean, if you kept going out with this, the next one's going to be somewhere around 16,000, and then it's going to be around 32,000, and then 64,000, 128,000, and so on and so on. Okay, it's a little like, I don't know if Mrs. Stone's ever talked about cell reproduction.
Not yet.
Okay, but I mean, that is exponential growth because you start off with one cell. Okay, for some animals, one cell splits into 2 cells. That's not a very big growth, but each one of those new cells is going to split into 2 cells, and then each one of those new ones is going to split into 2 cells. And if you look, this is that whole exponential stuff here. Okay, because this is 2 to the first power, 2 to the second power. This is 2 to the third power, and you keep doubling. 2's keep doubling that. Now, with exponents here, just a couple special ones to keep in mind here. If you're talking about something to the second power, okay, sometimes we don't call it the second power, we call it being squared. Okay, so when you see an exponent of 2, that's the same thing. You can just say this as being 3 squared. Okay, 3 squared is 3 to the second power. Just like 3 to the third power is, anybody? We don't have to say 3 to the third power. We say cubed. Cubed. Okay, 3 cubed. Anything after that, we just say to whatever power. 3 to the fourth power, 3 to the fifth power. But usually if it's a 2 or a 3, we call it 2 squared, and we call 3's cubed. Now, just so you can put this in your notes, I don't know if it'll come up in the book, but we'll do some special cases here. How about anything to the first power? 3 to the first power, what do you suppose that is? Anything to the first power, Mason, is
3
correct. anything to the first power, anything to the first power is itself. Anything to the first power is itself. Okay, 3 to the first power is 3. 10 to the first power is 10. Which probably leads you to ask what question? What do you think I'm going to ask you next? Nick?
Well, why, that would just be 3 times 1. That would just be times.
No, it's just 3. Don't. Because what the exponent tells you is how many 3's you have multiplied together, and this one you only have 1. 1 3. Now this one's going to blow your mind if that one's it. What about anything to the 0 power? Anything to the 0 power is. Who's going to take a shot at this? Alexa.
0.
It is not 0. Gary?
Is it itself?
It is not itself. That's what anything to the first power is itself. You can get too many options left. Mason?
30?
It is not 30.
Oh.
Nor is it 3 degrees. 3 to the 0 power is, Nick?
It's self-negative?
Nope. Write this down, and I won't explain it. We'll get to it later in later years of math. Anything to the 0 power is 1. Anything to the 0 power is 1. We will talk about that when we get to a little higher math, but right now just take it for that. So if you have 75 to the 0 power, that equals 1. Just the way it is, just accept it, enjoy it, believe it. I would not lie to you on that one there. But I'm very sure about that. Now, when are you going to use this? Well, here's what the book is going to ask you to do, so write this down here. It will ask you to write 4,500,000 Oh man, we got a lot to talk about here. This is still under exponents. Write 4,500,000 in expanded form using exponents. Now, before we talk about that, I should have talked about this a little bit before that. The nice thing about exponents is they can make things a little shorter and a little simpler for you. One of the things we like to use exponents a lot with is tens, because tens are really easy to use exponents with. For example, let's just do this. 10 to the first power is 10. 10 to the second power is 10 times 10, which is 100. 10 to the third power is 1,000. 10 to the fourth power is 10,000. And 10 to the fifth power would be 100,000. Now you can see why this is so easy, because can anybody see a little pattern there?
Yes.
Whatever the exponent is how many zeros there are. 10 to the fourth has 4 zeros, 10 to the fifth has. Now, normally when we were asked to write that in expanded form, you would write this. You would write 4 times 1 million, because the 4 is in the millions place, plus 5 times what? 100,000, right? Because the 5 is in the 100,000s place. But since they asked you to write it using exponents, rather than writing out this great big 1 million thing, you're going to write it as 4 times 10 to the, how many zeros does a million have? 6. So it's 10 to the 6th power, plus, maybe we put this in parentheses, did we? I think we did. Plus 5 times 10 to the, well, how many zeros in 100,000? 5th power. So it's a lot shorter and a lot quicker to write rather than writing all those zeros out there. So they will ask you to do that. Maybe we should try one more. How about this? What about 7,650,000? Write that in expanded notation using exponents. Expanded notation using exponents. Toughest part about this is just figuring out what the exponents that go with the tens are, because you know you got a 7, a 6, and a 5, but really it's not that hard. What is the exponent of that 10 going to be? And what's an easy way to figure it out? Else it is 6. And a simple way to think about it is however many digits are after the 7, that's the exponent, because that makes that 1,000,000, and that's what that would be. Same thing with 6. How many digits come after the 6? 1, 2, 3, 4, 5. So this is 10 to the 5th power. How many digits come after the 5? 4. So this is an expanded form using exponents.